Hey everybody, and welcome to VMware Tanzu Standard Session. I'm Owen Penso, and I'm a technical leader for emerging technologies in the Modern Application Platforms business unit in VMware. In the next 20 minutes, we will go over Tanzu Standard, the components inside of that, and we will have a demo to showcase the technology. Let's start. First, let's go over the Tanzu portfolio. The Tanzu portfolio is robust and have three different pillars: the build, the run, and the manage. The Tanzu standard package is around the run and the manage. How do you provision Kubernetes clusters on-premise and off-premise? And then how do you manage that in a consistent way across all of those different infrastructure providers? In addition to the Tanzu standard, you can integrate into two of the services of the manage, that's Tanzu Observability and Tanzu Service Mesh. On those components, we can do a different session, but for now, let's focus on Tanzu standard. So the Tanzu standard is starting with the Tanzu run, and the Tanzu run is divided into two main layers. The one is the foundation itself, and that's Tanzu services inside vSphere. That's more for focusing on the infrastructure layer and answering the demand and challenges of the VI admins or the infrastructure managers. And the second layer is Tanzu Kubernetes Grid. Tanzu Kubernetes Grid is an open source, aligned with the community upstream Kubernetes layer that has consistency across different infrastructure providers. So the way that you're provisioning Tanzu Kubernetes Grid on vSphere is exactly the same way you will provision that on AWS based on EC2s or on Azure based on Azure servers. Those two different layers are, as I said, answering the challenges and the demands of two different internal customers or consumers. The VI admins will have their own tool sets and skill sets using vSphere, vCenter, and the common tools of VMware to enhance vSphere with Kubernetes and to expose new services. And from the other end, the developers and the DevOps engineers will have an open source way to consume Kubernetes, and it's going to be consistent across any cloud so they can interact with different clouds seamlessly. So that's the Tanzu run, and that's the first layer in the chain. Let's deep dive into the first layer. The foundation itself, as I said, is enhancing vSphere with Kubernetes services. That means that now each and every one of your vCenter cluster can be actually a Kubernetes cluster by itself. That will allow you to interact with that vSphere and vCenter clusters with API calls of kubectl. Kubectl is the API of Kubernetes. And that will also allow you to provision and create different objects inside that vSphere in the construct of Kubernetes. So you can create a namespace that is a logical boundary in Kubernetes that will be represented in the vSphere environment in the vCenter as a resource pool. You can provision virtual machines or virtual pods, and those pods are just upstream pods running directly on the ESXi itself. That will also allows you to leverage that capability of the ESXi as the runtime environment. It will be more secured because it's an isolated OS and it's curated by its form. It will also bring you a lot of value in the performance side because running pods directly on ESXi, it's just like running that on bare metal where the ESXi is the OS itself. And you can have that common ground of all those objects running in the same declaration method, running according to a manifest with Kubernetes controlling them and the reconciliation of them if something goes wrong with any of those. You can see one of the clusters is a Kubernetes cluster, one of the objects. Now, a Kubernetes cluster built in on Kubernetes, that's based on Cluster API. Cluster API is the lifecycle management engine from the community, and it's addressing Kubernetes cluster as if it's just another Kubernetes object. That will allow you to use Kubernetes to provision Kubernetes. So let's go over a bit about Tanzu Kubernetes Grid and Cluster API. Cluster API, as I said, works with Kubernetes and a new object that we are introducing to that. That's called a custom resource definition, a CRD. That object expand the scheme of Kubernetes to introduce a new object, and that object is a cluster. When I'm saying what's the desired state of that cluster, I'm basically describing the cluster itself. How many control planes, how many workers, what's the size of the VM, what's the data store that it will be provisioned on, or the storage that it will be provisioned on, what's the IP stack, the IP CIDRs that will be used in that cluster. And then I'm deploying that, I'm applying that YAML file on a Kubernetes cluster. that Kubernetes cluster, the foundation or the management control point for that installation, will now provision different clusters. And all of those different clusters will be running according to the intended state, according to the desired state. Everything is based on cluster API and Kubernetes control plane without any change. So we didn't fork anything, we didn't change anything. We are contributing to the community a lot in those aspects. And we just got another company, another huge vendor utilizing the same mechanism, and that's AWS using cluster API inside EKS. You can see it becomes the standard de facto of the community for lifecycle management and everything around it. So let's go a little bit about Tanzu Kubernetes Grid. So I've said Tanzu Kubernetes Grid is basically leveraging cluster API, and it's creating your own regional control plane inside your environment. A regional control plane in vSphere will be a vCenter cluster or a vSphere environment. Now, the foundation cluster, the vSphere with Tanzu services, I've stated it first in the beginning, is actually that's actually the management point for that region. So that means that when you're applying a Kubernetes declaration file that declares a cluster, you're basically doing that directly on your vSphere environment, and that's acting as the management cluster itself. You can see here in the slide as well. Now, the lifecycle management is cluster API, but above that, you have Kubernetes, and you have to have additional services around Kubernetes. And we've said that it's more appealing to the open source community and the DevOps engineers, developers that wants that consistency across different clouds. To achieve that, we have to use open source tool sets in that aspect. And that's something that is bound or based or dependent on vSphere and VMware. That's why everything around Tanzu Kubernetes Grid is open source. If going from the network, it's going to be Anthrea for default CNI, but you can also use Calico. You can use Contour for layer 7 Ingress controller. You can use Harbor for the registry, Dex and Gangway for the identity management. And of course, for monitoring and logging, it's again open source leaded. So Grafana, Prometheus, FluentBit, and of course, VMware Tanzu Observability that will allow you to gain that visibility and matrix analysis across all of the different layers. So that's Tanzu Kubernetes Grid, as I said, built on open source. Now, when I have that regional control plane, I have that running in my vSphere, and now I'm leveraging the same open source way of doing things and cluster APIs, the lifecycle management, to run a cluster on AWS as well. How do I achieve that consistency of management? And what if my developer wants to use EKS or AKS or GKE because they want to utilize specific capabilities in different public clouds? What I'm doing is they want to be in charge of the operational side or the security side. How can I gain consistency across all of those different Kubernetes clusters, regardless of the infrastructure they are relying on? And that's exactly why we came into a global control plane. We came into the concept of we need something to manage everything on top of that different regional control planes. And that's our Tanzu Mission Control. That's part of Tanzu standard. And as part of that, you will have that cloud service that will help you manage any Kubernetes cluster as long as it's conformant on any infrastructure provider. So when I'm saying anything, I'm saying not just clusters that you're provisioning with Tanzu Mission Control, but also clusters that you're utilizing like EKS, AKS, GKE, and also clusters that is not VMware like OpenShift 4, Rancher, or something you've installed yourself, a DIY cluster. You can manage everything under the same global control plane with Tanzu Mission Control, and then achieve identity management, security management, policy management, and I will go over everything in the demo. It's important to see there's different layers, but in all of the stack, we are keep aligning with the community and the open source way of doing things. So we are exposing Kubernetes services as part of vSphere. That's an upstream conformant Kubernetes. We are not forking Kubernetes or changing that. We are then exposing Tanzu Kubernetes Grid with cluster API lifecycle management from the community with all the open source toolsets and projects that I've described before. And then we have Tanzu Mission Control that just add additional value and multi-cluster, multi-region management. And again, uses only open source toolsets in the backend. So for Data protection inside Tanzu Mission Control, we are leveraging Velero. That's the most common backup and restore mechanism for cloud native applications. For conformancy test and benchmark test, we are using Sonobuoy. And again, that's one of the key components inside the Cloud Native Computing Foundation. And we are actively contributing to all of those projects to be able to support you and to be able to, contribute back to the community around everything inside that stack. So that's a huge change and shift in the way that VMware is thinking about things and the way that Tanzu it's brought into market. With no further ado, I think I will go to the demo. So yeah, let's start. Okay, to the demo. So what we are seeing here is basically on the left side, I have my vCenter. You can see one vCenter cluster with 4 ESXi hosts. And on the right side, I have my console. It's just to show you the interaction with that cluster with kubectl API and kubectl command, just like any other Kubernetes cluster. What I've enabled in my vSphere environment, in my vCenter cluster, is I've enabled workload management. In that workload management, I can enable my Kubernetes services. I can see a namespace that is already up and running. But before that, let's go over the cluster itself. So I've enabled my vCenter cluster. It has one namespace, 4 hosts. It's running. And that's the API endpoint for that cluster. That means that when I'm doing kubectl API calls like get namespaces or get pods or just taking a better look on that cluster or nodes and everything else, I'm basically doing API calls to that IP. Now, behind that virtual IP, there's 3 different VMs that makes that control plane. If I will go back to host and clusters and I will open up my namespaces construct, that's my Kubernetes construct inside vSphere, I can see 3 VMs. Those VMs are the control plane for my vCenter cluster. I can see a namespace that I've already created with the name main Tanzu. If I will hover above that in the summary page, I will see a lot of different components and things that I can configure. But for our demo, let's create a new namespace. So I will right click on the cluster itself and I will choose new namespace. I'm going to call that a demo because we are doing a demo right now. And I'm going to create that. Once I'm creating that, I'm getting diverted into the configuration pane of that namespace. And now I can configure that namespace. So I can edit permissions. And those permissions can be from my SSO domain. I can add my user of DevOps into my, and give it an edit permission, or let's say the administrator. And I can add storage, and that will add a storage class in the backend of the Kubernetes. So I can choose my Kubernetes storage policy to my namespace. Now, each and every Kubernetes cluster has its storage class and persistent volume claims or other components that will bond into that storage class. That's the foundation or the basic layer of storage. And that's why we need to bond that storage class into our namespace. We can now create also capacity and usage or quota policies. Those quota policies will be deployed and basically it will be applied on any object in that namespace. And as I said before, those objects can be not just VM machines, it can also be a Kubernetes construct or a Kubernetes cluster. So in this case, I'm not going to limit anything. You know what? Let's limit the memory and the storage, 100 gigs. So 64 gigs memory and 100 gigs of storage. And I've enabled that in that quota policies. And I can also see down here a Tanzu Kubernetes section where I don't have any clusters running. So when I will provision Kubernetes clusters with Cluster API, just like I've said before, it's going to be provisioned in that construct, in that part. And you will see a Tanzu Kubernetes cluster running here. If I want to go and see better look on my Kubernetes side as a VI admin, I can inside my vCenter go to monitor and see Kubernetes events. I can go to compute and see deployments, daemon sets, a lot of different Kubernetes constructs. And I also have VMware resources. That's where I'm going to see my cluster and my virtual machines. I can also see storage components if I have one. In this case, I have only my storage class and network services if I will provision load balancer services and networks. If I will go to main Tanzu, in this case, I already have one Kubernetes clusters that is deployed in that. So if I will go to compute and Tanzu Kubernetes, I will see my object. My object is main Tanzu cluster 1. and you can see it has 3 workers that runs. That's the version of Kubernetes that's running, and that's the IP for the control plane for that cluster. That means that when I'm doing kube control API to that cluster, it's going to be those virtual machines that will be answering for that control plane. Now, in that case, you can see those virtual machines are basically a Kubernetes objects, just like anything else. And Kubernetes is the one to manage that. So when I'm doing API calls to that Kubernetes cluster, I can actually add another object and create another cluster. So let's do that. Now, the way that I can interact with that Kubernetes services inside vSphere is either with kube control API from that command line, or I can also use a UI for that. And for the UI, we have an open source dashboard that's called Octant. It's a developer UI, open source developer UI that we contributed into the community, and we are still contributing. And you can actually manage multiple Kubernetes clusters with multiple namespaces, and you can apply YAML files and applications directly from the UI. We will use that to basically deploy an application on our Kubernetes cluster, and after we will create that. So the first thing is to provision that cluster. Now, the easiest way to provision a cluster on vSphere will be to interact with Tanzu Mission Control. Tanzu Mission Control is our main control point, or the management console that we've said that can manage multiple regions, and not just vSphere clusters, but also different clusters like AWS, Azure, and Google Cloud, and others. Now you can see vSphere clusters that is provisioned here with version 1.18.5. Let's create a new cluster on vSphere. For that, I'm going to do create cluster, and you can see I have 2 different options. One is running on AWS, and the other is provision on vSphere. So I want to provision on my vSphere environment. That vSphere environment is my AJAS main Tanzu environment. That's the way that I call that. So if I will go to management clusters, I can see vSphere AJAS main supervisor cluster. That's my environment. In the provisioners, I will see the namespaces. So I can provision clusters to different namespaces. Let's choose the main Tanzu. I already have one cluster over there. Let's just create the second one. If I will create, I will click on next. I need to give it a name. In this case, the name will be main Tanzu cluster 2, because I have already cluster 1. I can add that into a cluster group. That cluster group will basically state which kind of policies the cluster will be applied on. So I will get into policies in a couple of seconds, but I'm choosing vSphere cluster because it's a vSphere cluster. In the configuration pane, I can choose which kind of version I want to deploy. In this case, I'm going to deploy the latest one, and that's 1.18.5. I can choose the pod CIDR and the service CIDR. That's an internal CIDRs, so you don't need to change that. If you really want to, you can. And by definition, it will automatically use the IPs that you've assigned to the vSphere supervisor cluster for the external IPs, for the load balancer of the control planes and the load balancer of applications. In the persistent volume storage, I need to choose my Kubernetes storage policy to basically state on which data store the cluster will be provisioned on. When I'm clicking next, I need to choose if I want one control plane or more than that, if I want high availability. And I can also change the size of the machine itself. So let's do large. And I will stick to Kubernetes storage policy, and I don't need high availability right now. Next, now I can actually choose the amount of workers, the amount of Kubernetes nodes, and again, the size of them. So let's again choose large and extend the number to 2 worker nodes in the same Kubernetes storage policy. By clicking on create cluster, I'm basically applying a kube control API command directly into my supervisor cluster. If I will hover above main Tanzu and I will go to compute and Tanzu Kubernetes, I will see there's a new object that was created here. You can see main Tanzu cluster 2, and it's being created right now, and the worker count is 2, and the version is 1.18.5, exactly according to what we've stated. In a couple of seconds, there you go, you can already see how it's provisioning that. So basically, it's deploying an OVF package from a content library. So it's cloning an OVF that is inside my content libraries, inside of my TKG content library. I will have different options or different OVFs. Now you remember that list. That list was in Tanzu Mission Control when I've chosen my version. It's basically an OVF packages that the supervisor cluster or cluster API is leveraging to clone that and then reconfigure that according to that specs of the cluster. So in the meantime, while it's configuring and creating that cluster, let's just do a simple demo on the one that I already have. So here I have my cluster one, and I have 3 VMs and 1 control plane. If I will go back into my Octant dashboard, you see I'm in my main Tanzu cluster one, that's the cluster itself, and I'm in the default namespace. I'm going to change my namespace into Nginx and see if I have anything running in the Nginx namespace. Now, that Nginx is being managed by Tanzu Mission Control. If I'm going back to Tanzu Mission Control, and I will go to clusters and Tanzu cluster one, that's my cluster. It's running on my vSphere AGS main supervisor. It's the main Tanzu namespace. It's running for workers. It has allocation CPU and memory that you can see, the health state of Kubernetes and the health state of the cluster itself. And it has also integration that we will go over in a second. But that cluster also have a namespace that is being managed by Tanzu Mission Control. That means that even if someone will delete that, that's a workspace and that's a cluster that is being managed by TMC Cloud. Even if someone will delete that, it will reconcile and recreate that. So let's try and do that. I'm getting namespaces in that cluster in main Tanzu cluster one. And again, I can see the Nginx. If I will delete that Nginx, I don't want it. I don't know who created that. I'm deleting that. And if I will now run again my kube control get namespaces, I will see it's just automatically created. Now it's not just for the namespace, it's for any object inside that management point. So basically, and if I will get namespaces again, there you go, Nginx, 3 seconds, and it's up. So if I'm configuring a policy or I'm configuring security or something else, that's the way that it's working. Kubernetes will reconcile if someone will try to override that. Now, you saw something that I've called a workspace. A workspace is a crucial concept or construct inside Tanzu Mission Control. A workspace allows you to basically aggregate multiple namespaces from multiple clusters and then apply policies on those. So I've created an Nginx workspace where I have 3 different clusters, one in Azure, one in vSphere, and one on AWS and one on vSphere. Each and every one of them has the Nginx namespace, and just like you saw here. And in policies, I can now assign policies for those. The easiest way to show a demo is by going to Workspaces, Nginx, and I've said to my developers in the image registry section, they have to pull an image from the internal registry just for security reasons. So if I will try to run Nginx directly from Docker.io in the namespace Nginx, I will get an error message. So let me just change the image. I'm getting an error message, and the error message says that it's forbidden. I can't run that image because it's not according to the policy. I've said to my developers that they need to pull from Harbor and not from Docker. So if I will run the same command again, but I will add my Harbor name, tanzuworld.com/opensource/nginx, that will run. So you see now the pod is being created and it's gonna run. Get pod -n nginx, and yes, it's running. So that's the easiest example of that aspect of security. But I can do the same also for access, for identity. It's not easy to manage identity across different Kubernetes clouds. So if I will go to cluster group and I will go to my dev cluster group, you will see different clusters here. So I have an AWS one, an Azure one, a GKE one, and I want to assign access for a user that doesn't have access still for that environment. So in this case, I'm just going to use my Tanzu Demos user. So that's a user with the name Tanzu Demos, and it doesn't have any access to any cluster right now. You can see the blank screen that he has. It doesn't have any access to download kubeconfig or interact with that cluster. The only thing I need to do to add permissions and access to those clusters is to choose which kind of role access I want to add. In this case, I'm going to add admin, and I'm going to do Tanzu demos at gmail.com in this case, add, create, and that's automatically injected roles and roles access to those clusters If I will refresh the screen on the right side, you will see now I have access to all of those clusters. And again, that's different infrastructure providers. It's not something that is easy to achieve when you need that across different Kubernetes clusters. So two less things about that: integration points. When I will get into one of the clusters, let's say take the AWS one, if I'm provisioning the cluster from Tanzu Mission Control, in this case, it's AWS, not vSphere, but it's again a cluster that I've provisioned. You can see I have a bubble here saying upgrade available. If I will go to action upgrades, you can actually see I can upgrade my cluster, and it will canary upgrade automatically the cluster itself. If I want to extend or resize the number of nodes, and you can see there's 6 nodes, I don't need 6 nodes for that cluster. I can either resize or reduce. I can go to node pools and basically change that from 5 to 4, let's say, save. And now I would have one control plane and 4 workers. Another important key factor inside that cluster or that integration points is that I have an integration points for Tanzu observability. So if I will click on action, Tanzu observability, and I will open that up, I will get a dashboard with observability matrix for that Kubernetes cluster. That's not part of Tanzu standard, but it's an integration point, and you will be able to do that if you're acquiring Tanzu standard. It's an additional service called Tanzu observability. So you can see a lot of different metrics, and you can see a lot of CPU usage and networking and a lot of other components across the observability of the Kubernetes cluster. But it's not just that, because Tanzu observability has the capability to integrate with more than 200 integrations to all the stack. So infrastructure, cloud, in this case, it's AWS, so EC2s, Kubernetes as an application platform, data services, other monitoring solution, or even application. And if I will go to application and service dashboard, you will see an application context view of that same application that I'm monitoring. So request rate, errors rate, latency. And if I'm checking one of the slowest request, I can also see tracing of that application with microservices connectivity and understand what's the method that actually slowed me down. So there's a lot of visibility inside that Tanzu observability. Going back to Tanzu Mission Control, you can see I have a failure inspection. So that cluster is failed a CIS benchmark inspection. If I will go to inspections, I can see that dev AWS TBS, it was passing the conformance test. So it's a conformant cluster, but it's failed the CIS benchmark. If I will click on that, I will see why. So I have 11 failed issues that I need to basically configure to be aligned with that CIS benchmark. Last thing is the backup and restore. If I will click on one of them, I can go to create a backup in data protection, and I can decide if I want to backup the entire cluster, just the namespace, or according to label selector. If I want to do that now, hourly, daily, weekly, or monthly, and what's the backup retention. That will allow you to backup any conformant Kubernetes cluster, and everything that I've showed you in this demo is applicable for clusters that you're attaching, not just cluster that you're creating. And the lifecycle management aspects will be enabled just for clusters you provisioned. But if you're attaching a cluster, just like I did here for GKE, and I can click on that and see exactly the same thing, if you're attaching a cluster, you will have all the capabilities except the lifecycle management. To attach a cluster, you're just clicking on attach a cluster, give it a name, let's say test, cluster group again, let's say test clusters, next, and you're applying that command line. That's it. That will install whatever needs it, whatever TMC needs in that endpoint, and that will allow you to basically manage that cluster. Yeah, so that's basically a Tanzu Mission Control. And the last thing is the security insights. So one of the things you can do is to apply security policy on clusters. Once you're applying security policy on clusters, you can decide if it's a strict policy or if it's not a strict policy. But even if you're creating the most stricted policy with pod security policy or OPA policies or whatever, you can apply all of the different features and then say it's not enforced. Once it's not enforced, but it's still configured, you will have security insights. In the security insights, you can actually see all the different insights across all the different clusters. In this case, you can see in my vSphere cluster that the Nginx that we are running is running with privilege escalation, and that's not allowed from the security side. Again, that's something that you can enforce or not. But in this case, I'm not enforcing anything. I'm just getting that insight on that. So let's go over what we saw in the demo. We've started with vSphere with Tanzu. We've created a namespace. In that namespace, in the Kubernetes side, we've configured basically permission, storage policy, quota policies, and clusters. And then the only thing we do is basically provision cluster from Tanzu Mission Control. And that's allowing us already a lot of different capabilities from backup and restore, identity management, the provision itself, upgrading, tracing, inspections, and of course, integrations to other components. I hope it was useful. I hope you enjoyed that. Thank you for taking the time. And I guess we're going to go over to Q&A now. So again, thank you, everybody, and see you.